Deep within the cosmos, an event of unprecedented scale has unfolded. Two colossal black holes, each hundreds of times the mass of our Sun, engaged in a violent celestial dance.
Their ultimate collision created a single monstrous black hole, breaking all previous records. This cosmic titan now defies our current understanding of how such objects form.
This astonishing smash-up was detected by the global network of gravitational wave observatories, LIGO in the United States, Virgo in Italy, and KAGRA in Japan. The signal, officially labeled GW-231123, was captured on November 23, 2023, during the LVK network's fourth observing campaign.
The two black holes involved had estimated masses of about 100 and 140 times that of the Sun. Their merger resulted in a black hole exceeding 225 solar masses. Not only was this the most massive merger ever recorded, but the resulting black hole was also spinning at extreme speeds, close to the theoretical limit set by physics. Professor Mark Hannum from Cardiff University highlighted the profound challenge this discovery poses. Black holes of this immense mass are forbidden by standard stellar evolution models. One leading hypothesis suggests these supermassive black holes might have formed through earlier mergers of smaller black holes. It's a cosmic game of billiards, but with immense gravity.
Gravitational waves are tiny ripples in the fabric of space-time, born from the most violent cosmic events. Think of them as echoes from the universe's most dramatic collisions.
These waves, traveling at the speed of light, stretch and squeeze space as they pass. Though incredibly faint by the time they reach Earth, they carry invaluable information about their cosmic origins. The extreme mass and rapid spin of the black holes in GW-231123 truly pushed the boundaries of gravitational wave detection technology.
Extracting accurate data from such a complex signal required advanced theoretical models that account for the intricate dynamics of highly spinning black holes.
Dr. Charlie Hoy from the University of Portsmouth noted that this event serves as an excellent case study. It's pushing forward the development of our theoretical tools. Dr. Gregorio Carullo from the University of Birmingham anticipates years of dedicated work to fully unravel this intricate signal pattern.
This discovery heralds a new era for gravitational wave astronomy. Detectors like LIGO, Virgo, and KAGRA are revealing cosmic secrets unimaginable just decades ago.
Dr. Sophie Beeney of Caltech emphasizes how such events push instrumentation and data analysis capabilities to the very edge of what's currently possible. This is a powerful example of how much we can learn from gravitational wave astronomy and how much more there is yet to uncover. The universe continues to surprise us, offering profound challenges and inspiring new avenues of scientific exploration. The story of GW-231123 is just beginning.